We need to find out resultant or force on a pole where three identical poles are placed at the three corners of a equilateral triangle. What do you mean by that? Let us see. There is a pole of pole strength M, another identical pole of pole strength M, mean to say both are north poles. There is another similar pole who is also north pole. If these three are placed at three corners of an equilateral triangle, what is the force on any corner? Is the kind of question. First of all, to solve this, we need to know the formula. That's what is the force between two magnetic poles based on inverse square law, who is F is mu naught by 4 pi. Between any two poles of force length M1 and M2, when they are separated by a distance R square. Now I don't know what is this side is. Let me call it like A. Now let this is the pole I want to calculate what the resultant force is. Who is a north pole? Of course, all other poles are also north poles. So on the north pole, who is on that pole? This pole as well as these two poles at the base applies a force of repulsion because they are similar poles. Here mu naught is permeability of the free space, who is a property of that free space. That is the ability of that free space to pass the magnetic field through it. Well, so on this pole, this north pole applies a force of repulsion because they are similar poles. So this pole will try to push this away with a force F. How much is that F? I can write. What's the value of that F is? F is mu naught by 4 pi. This is M and this is also M. So M and M by distance square, that is A square. So parallelly on this pole, there is another pole who is applying a force of repulsion because this is also a north pole and this is a north pole. Between these two forces, similar, there is a force of repulsion. That is also the same value of F because the pole strengths are same, the distances are same. Now what we can see is there are two identical forces F and F separated by an angle theta. How much is this angle? Is as much of this. Because it's an equilateral triangle, that angle is 60 degree. So there are two forces F1 and F2. F and F, both are identical, has an angle 60 degrees between them. Now force is a vector. We will follow the vector laws of addition. When there are two vectors with an angular separation, what the resultant force is? We can use parallogram law. F resultant is root of F1 square plus F2 square plus 2 F1 F2 cos theta is the resultant force using the parallelogram law of vectors. Now F1 is F as we have proved. F2 is also the same. Cos theta, theta is 60, I will substitute that later. So this F square and this F square is 2F square. This is another 2F square. I can take 2F square common from both the terms. 1 plus cos theta. In trigonometry there is a formula. 1 plus cos theta is 2 cos square theta by 2. So that is square root of 4F square cos square theta by 2. That is 2F cos theta by 2. But we have already found the theta value is 60 degree. So 60 by 2. So that is 2F cos 30. What is cos 30 is sin 60 root 3 by 2. So this 2 and 2 gets cancels. This value is root 3 times of F. What is that F is? We have already found M square by side square. That's the resultant force acting on the pole at any corner, right? Now, once you found the resultant, I also want you to find out where its direction is. This is F. This is another F. These two are being equal. This F resultant will be exactly in between them. This is what we have found now. Whose direction is this? Whose angle will be at 30 degree between these two forces. That's how we can find out if all these poles are identical poles. Now, I just want to extend this discussion a little further by saying, what if these two poles are not similar in nature, but they are opposite in nature? Mean to say, this is a pole of pole strength M. This is also a pole of pole strength M. Well, this is a north pole, but this is a south pole, separated by the same distance. Let on the third corner keep the same north pole. At the three corners of an equilateral triangle, I want to handle what is the resultant force at this corner. What makes a difference? On this north pole applies a repulsion. That's the value of F, the same as the earlier case. But on this north pole, being is the south pole, it applies a force of attraction. Its value is same, but the direction is different because it's attracting towards it. So the same two forces like the previous case, but the angle between them is different. How much is that angle? This is an angle 60 degree. This is an angle 60 degree. Exterior angle is the sum of the two interior angles. So that value will be 120. So the problem is same, but the answer is different because this pole is changed its nature to south pole. Now the same formula, two forces with an angle. F resultant as I have derived is 2F cos theta by 2. But this theta is not 60 here. Earlier it is 60. Look at this diagram. Yeah. Here is the total angle is 60. But here the angle is 120 degree. So what will be 2F cos 60 because 120 by 2 cos 60 is half. So the answer is F itself. U naught by 4 pi m square by a square, where a is the side. It's not only resultant magnitude gets changed, its direction also gets changed. This is one F, this is one more F. The resultant will be exactly between these two with an angle 60 degree from any of them. So this resultant is here. If you remember, the earlier case of the resultant is in an upward direction. So they are quite different, right? So be careful about the forces that we are handling. Whenever there is a vector, we shall worry about not only magnitude but also about its direction too. That's how we have to solve the problem. Thank you for watching.